for us. We did not know how it would behave. And the whole idea of the whole goal of the benchmark here, of course, was time. But most important than time, which we always forget, is the tool life. The tool life here was pretty important, and they were getting their current cutting strategies and methods. They were getting a tool life of about 200 parts for a 4-diameter ball nose cutter, and about 30 parts for a 10 millimeter end mill.
Yeah, Amod, if you just can already show some pictures, please.
Yes.
Thank you very much. Please continue.
Thank you. This part. You can see it on my screen. It's held on my fingertip. Okay, and this is the size of the part. It was 20 by 10 by 12. It's a pretty small part. And the kind of tool life that they were expecting was more than what they're getting. And after a couple of iterations, we learned a lot of lessons in this cutting, because it was new material for us. And the biggest lesson that we learned on this particular part was not to use turbo on Inconel material, especially 625, not to touch turbo, because although turbo used to give us nice cutting, but our tool life used to dramatically go down. So we moved away from turbo. And with our current strategies, mixing iMachining with HSM and a bit of 2.5D, we could push the tool life of 10-diameter end mill from their existing current 30 parts to about 60 parts. And the 4-diameter ball nose, in fact, was doing very less for them, and they were getting 200. In our case, the center slot was completely roughed out in iMachining using a 4-ball nose cutter. Again, a new lesson for me. And what we achieved was about 400 plus parts on this, where the cycle time of the company was about 11.5 minutes, and we brought it down to about 5.5 minutes with iMachining, HSM, and 2.5D. But majority of the role was played by iMachining in this case. And this is a big win for us in that territory, because it's already UG out there. We're very strong in this account. You can also look another perspective of the part. I've kept a small coin, and just to show the size of the part against the coin. That was the size of the part. We had to check everything using magnifying glass, what kind of finish we're getting, what is the tool wear happening, because it was very difficult, because the whole thing is covered by coolant. So 2 major gains. First one, tool life dramatically up almost two times on Inconel. And the second one is the time down almost 50%. Eddie?
Yeah, Amod, the most important question for me, did we got the order? Did we win the deal?
Yes, we already won the deal.
Good job. Good job, Amod. And now we will make Anthony presenter, and just to show you that we don't stop. Even we have this amazing power in our hands, our team of developers for iMachining continue to work hard to keep it out of the competition. Anthony, I'll make you presenter right now. You are unmuted now. And thank you again for waking up so early for us. We very appreciate it. Thank you, Anthony. You can start.
Hi, Eddie. Can you hear me now?
Yes, you can start, Anthony. Thank you.
Okay, great. Thanks, everybody, and thanks to Ahmad for showing that awesome example. I can say I never ceases to amaze me what our resellers and staff and customers cut, and such cool things people do with iMachining. When Ahmad started talking about Inconel, the last thing I was expecting to hear was that the part was sitting on his fingertip. So yeah, really exciting stuff, and yeah, it's really nice for the iMachining guys to see how nice parts our resellers and customers cut. So let's get started here. So we're going to talk about what's new in iMachining for 2016, and as Eddie has said, we really have a great tool in iMachining, and we've put a lot of effort into it, and naturally all of you guys have seen that over the years with 2D iMachining and 3D iMachining, and now we wanted to do some new things to really make programming easier, and all these things are feedback that we've heard from resellers, customers, and things that we've analyzed from customer parts. Anytime we get examples from customers, we're always looking to see how they use the tools, and these are the new things that we've done because of that. So basically, there's three main things for 2016 we did. The biggest one is the optimized finishing of 2.5D features. The second one, and this was really highly requested from customers, was removal of the material left over by the pre-drill tip, and I'll explain that later if that's unclear. And then fixture avoidance for iMachining 3D. So I think that one's a really cool, exciting one, the fixture avoidance for iMachining 3D. Now, what you guys will notice right away as soon as you get into using iMachining 2.5D is we now have a new technology type called iRough and iFinish. And we've also updated our existing technology type of iFinish, which it now also includes iRest if it needs to. Naturally, that's probably not clear right now, but once I get into showing this on the part, you'll understand better what we mean by that the iFinish also includes iRest. To understand why we did all the finishing stuff for 2.5D, it helps to kind of understand the way people use the software today. And I think everybody here knows that usually customers and resellers were using some combination of iMachining, pocketing, and profile to optimally rough and finish 2D pockets. This can lead to many operations. This can also lead to the user having to track their parameters between the operations. Things like wall offsets. You need to know what wall offsets you leave. So when you go to other operations, you know what lead in and lead outs to define. So that way you plunge out in there. And all these things are tracked by the user as he's going from operation to operation. And then there's always the cycle time. So if we're using these different tools and these different operations, how do we get the shortest cycle time possible? So with that said, now I don't like doing too much in PowerPoint. Just wanted to set up a few ideas here. We're going to jump right into SolidCAM and SolidWorks. So the first thing I just want to mention real quick is the existing style we use today. Just so because I think this sets the stage for what what we're doing today and what I'm going to show you next. So if we have a pocket. Normally we're going to have some, as I said, combination of iMachining for roughing the pocket. We're probably going to have, we could finish with iMachining on the floor, or we could go to a pocketing style toolpath to finish the floor. And this is something we see a lot of people do, that they finish with iMachining on the floor to get this more traditional, looking finish on the part, as opposed to the iMachining, spiral look that you get on the bottom of the part. Then you might have some rest machining to cut in between areas that the larger tool didn't finish. You might have some finishing of the floors in those areas, or maybe you use a smaller tool to finish the floor for the entire thing. And this is always left up to the customer how he wants to do this and what tools he wants to use. You might end up finishing the corners. Some customers, you could use iFinish to finish the corners and to finish the walls. Customer could use something like pre-drilling to drill out the corners for finishing the wall. Or somebody might just end up doing lots of Z-level cutting in a profile operation to finish the wall. So there is no right and wrong way for a customer to use these tools. SolidCAM is a toolbox. It's meant for them to figure out the right way. So in the end, the customer is trying to find the best optimization of operations, tool diameters, what tools does he rough with, what tools does he finish with, and he's always trying to make those decisions how he wants to cut the part using our multiple strategies. Now, I'll close this part. And let's get into actually seeing what we've done in iMachining. So I have a part here. Basically what we got here is a 2.5D part. It's kind of modeled after like an aerospace bracket. we have something we can cut around the outside. We have some semi-open pockets and faces, and we also have some closed pockets. So I'm going to go ahead and show how, with the new tools in 2016, how you can use iMachining to do the roughing and the finishing of walls and floors, and how all that connection works. So I have some previous operations in here. I'm going to leave them in there because I might unsuppress them at times just to show some things, because I don't, we'll see how quickly things progress. So let's just say we want to start off with 2D iMachining, and naturally the first thing we want to do is cut the outside of the part. So we'll go to 2D iMachining. As I mentioned in the slide, we now have an iRough and iFinish in the technology type. And what I want to do is I do want to rough and finish the outside of the part. So with one tool, I want to be able to rough and finish the outside of the part, and then move on to my inside pockets. So what we'll do here is we'll define our geometry. So we pick the outside stock. I apologize, didn't want to do that. Let me pick the bottom. So we have our 2 chains. We want to mark the first chain as open. Now we want to go grab our end mill. So what I'm going to use is I'm going to use a 16mm end mill. So this tool is big enough to get all the way down through the part, but it is not going to be big enough to finish a couple of the small corners we have in there. But still, we want this big tool to basically finish as much of the outside as possible, and we only want to use a small tool just to finish the corners. So we'll select this end mill. We'll select our levels. So we want to machine from the top. We want to machine down to the bottom. Let's say we want to go down, a 0.5 millimeter extra. And now, if you look, there's not too many dialog changes that you guys are going to notice here, which is actually really cool. The software doesn't add too much in the UI, but there's a lot of stuff going on in the background. So we have, our standard wall and floor offset. In this case, I'm not going to finish the floor because we're cutting the outside of the part. Now, even though we're cutting the outside of the part, it's always possible. Maybe that's like a fixture, and when you flip the part over, you're going to locate on it. So, maybe you do sometimes, finish the floor if you like. But we're just going to go to 0 on the floor offset because we don't have to worry about finishing the floor. We also now have a semi-finish. There's no point in having the semi-finish. And I'll pick compensation, and I'll pick a large lead-in, lead-out move. I'll be clicking the large lead-in and lead-out move just so when we look at the toolpath, you'll be able to see, where the final wall passes. And we'll just save and calculate this operation. So here we can see we have the iMachine toolpath. It roughed out. And, with our large lead in and lead out, you can see we also get the finishing tool path around the wall. So if we actually simulate this, and now that we've actually cut the stock, there's no point to see that anymore in SolidWorks, so it'll make the simulation be a little nicer. Turn on the holder. So we get the iMachining roughing. It roughs to the wall offset. We get our typical iFinish where it cleans out the corners first, and then it does our final finish pass along the wall. And what we have right now is we have some material left over in just these 3 corners. But we've already finished the majority of the wall with this large tool. For anybody who used iFinish in 2015 and previous, you would know that you could do iFinish. It was an existing technology type, and you could finish the wall with iMachining. One thing you could not do is you could not finish the wall with one tool and then go and do rest finishing in the corners with a smaller tool. So now that limitation is, we've optimized it now that now we allow and we calculate rest material for iFinish, so you can come in and do a smaller tool. which is what I'm going to do here. So I'm just going to do a save and copy. I'm going to go select my smaller tool. So here we have our 5mm tool. The 5mm tool is long enough to get all the way down there. We will select that. Now what you'll notice is also the technology type auto switched to iFinish. That's because now we know that the operation that it's linked against was the iRough, and we know and it was iRough plus iFinish, so the only thing you can do now is iFinish again. So we've also added some little UI things that auto select stuff to make the software a bit more intuitive and make things a little quicker to program. So here, with a small tool, a semi-finish can really, be a nice thing. So with semi-finish, we'll also get an extra tool path, because we're going from 150 microns all the way down to, then we can take a second pass at 80. So if we simulate this and calculate, now you can see we have just iFinish toolpath in just those areas. And we'll quickly simulate this. This outside is pretty simple. When we get into the semi-open pocket, I'm going to go over more of the each part of the toolpath that we're doing with the roughing and everything. So we'll finish this. So now we have our corner finished, and this is, as I said, a new feature now in 2016 that you can now finish after an existing tool with a bigger tool. And what you've also noticed is that with the iRough, you can now do roughing and finishing in the same operation. So in the previous version, you would have to do iRough and then iFinish, but now we've combined those two tools into one technology type. Okay, so now let's do some of the more exciting thing and actually see all the floor finishing and how that works. So we're going to add a new 2D iMachine. We are going to define our geometry. So there's our pocket. As we know, we need to mark our open edges. So we're going to do our from to. So that way we get from this ledge to that edge, and we mark that as open. And I'll just call this ledge 1. I don't think I have that geometry named. Nope, of course I already had the same name. Now what I do want to do is I'm going to do iRough and iFinish on this. So we're going to pick iRough plus iFinish. We are going to select our first 16mm tool. Oh, I apologize. We wanted to do iRough. So we're going to do iRough. We want to select our pocket depths. Okay, now when we do iRough, we are now going to finish the floor with a pocketing style toolpath. So let's simulate this operation and see what we get. I'm going to rotate this to more of a isometric from this side. So we are going to get the iRough, and I'm simulating this slow so we can properly see what's going on. So we get the iRough. The iRough is staying away from the wall by the wall offset amount. Then once the iRough is done, we are now going to finish the floor with this tool. So now you can see we automatically get the tool leading out in air. And I will just single step this. And now we get the finishing of the floor. Now I want to show some little features of what we're doing. If we zoom in here on this corner, since we are now tracking what is being roughed and what is being finished from iMachining, we can make some smart decisions about how to lead in and lead out in the air, and also to keep the tool from hitting existing material. So what you see here is, this little ledge is showing that when we finish the floor, we know the wall's not finished, we know the wall's roughed. So we stay away from the wall a little bit, so that way the tool is not actually hitting material along the entire flute. So as we know from finishing, the best way to get the best finish is to keep the load as less as possible. So last thing we want to do is when the tool goes into a, we don't want the tool to get excess loaded, like going into a corner or rubbing against the wall, because the tool ends up flexing a little bit, and when it flexes, the tool digs into the floor. And I can tell you that we've done a lot of test cutting with all this finishing stuff, and a lot of these little things we did was a result of, one, what we knew from being machinists, and two, what we saw from test cutting. So I mean, we cut steels, we cut titaniums, we cut aluminum, we did many different size tools. So a lot of these little things we did is from our test cutting and trying to prove out, what was the best way to do these things. So we see now, so we got an eye rough, and we can finish the floor with a pocket style. You can still finish the floor with an iMachining style if you like. So we are going to now, let's save and copy this operation. And now we're going to do iFinish. So we're going to switch to iFinish. We will go switch to our secondary tool. So our secondary tool we have is a 10mm end mill. So this end mill is a little bit smaller, but it's able to finish the corners. So we will select that. Levels, everything stays the same. The operation is linked to the previous one. This is a pretty big tool, so we don't need our semi-finish. We will do compensation and our large lead in out move, so we can see that again. And we'll calculate this tool path. So let's actually go into the simulation and see what's going on now, because now this operation knows that the previous operation did roughing, it knows the previous operation finished the floor, and it knows the wall offsets, the floor offsets, it knows everything that the previous operation did. So what we're going to see now is a very optimized tool path that keeps the tool from not plunging on material and being very optimized. So what we're going to get is we're going to get our traditional cleaning out of the corners. So I'm trying to single step this stuff so it comes through nicely in the webinar. So if I zoom in on this area, so you can see here's, there was a lot of material left over from the large geometry fillet and from the eye rough. So the corner is now brought into to the constant wall offset. Then we get our iFinish preparation, which this is where the tool goes all the way. It basically finishes to the floor, to the wall, but it stays away just a little bit. And for anybody who's used iFinish, this is how iFinish always worked. We always had those little corner tool paths where any area where the tool would over engage on the finish wall pass, we clean those areas out basically to almost a zero wall offset, so that way the tool doesn't over engage. So we get this in both corners. And now what we are going to get, and we'll let the first one play because this should be doing the floor. And what I'll do is I'll actually turn off the tool for a moment, and we'll zoom in. So you'll see the orange cutting here down at the bottom. So here's what the tool's cutting. So we have the corner basically finished, and we have it prepped. now we need to clean out the floor excess material. So you get now the floor brought in, and let me turn the tool back on. You are going to get now the tool also going all the way to 0. So the wall gets cleaned all the way to 0. Then we get our final finish pass along the wall. Now, what we've seen now is that you can now iRough. You can finish the floor with an iMachining style toolpath or a pocket style toolpath. When you do save and copy and you make a link, the iFinish knows if the floor was finished, if the wall was finished, and now we're correctly adding all the little toolpaths we need to make sure that the finishing can be done in, one Z step. That's always the big thing with iMachining finishing from iFinish is we want to do one Z step. So we need to prep the corners, we need to clean out the rest material, and we also need to finish the floor. As we mentioned before, one of the main things to make sure that we handle properly is that when the tool is cutting the wall and finishing it's only touching the wall. And when it's finishing the floor, it's only touching the floor. We don't want to end up in a condition in iMachining where we want to be finishing the wall and it's cutting excess material on the bottom from the floor offset, and therefore adding some extra load and possibly digging in on the floor. So these are all little things we're doing in the background to make sure you get the perfect tool path. Now let's look at how we would program that ledge using our existing tools. So I'm just going to suppress these two operations, and well, let's say we can take the iRough, because in an existing, the way everybody would work today, we would use an iRough. But let's say we wouldn't finish the floor with the iMachining. So we would just we would do an iRoughing toolpath. This would clean all the material away, leaving our 0.3 on the floor and our 0.3 on the wall. Then we would go to something like a pocketing operation. So let's go into pocketing. We would try and share geometry because we can. So this is our ledge 2. We will go select our the same tool. So we'll go use that same end mill that we were using. Now, since we've already roughed the entire pocket, when we finish the floor, we don't want to start from the very top and go all the way down. So what we're going to do is we're going to set our upper level and our pocket depth to basically the bottom. And what we're going to do is we're going to tell SolidCAM that we have the 0.3 worth of material on the floor, because that's actually where the material is stopping. We are going to, let's say, put a wall offset of at least 0.3, because 0.3 would be the wall offset from iMachining. But as we know, we don't want to go right to 0.3. We want to put some excess in there. So let's say, 0.35 or, 0.4. So if we calculate the tool path, so we can see here's our tool path. Of course, I know we're doing a semi-open pocket, so we also want the tool to go plunge out in air. So we're going to go into the open pocket settings, and we're going to say approach from outside because we have the area, so we'd rather see the tool do that. So let's simulate this. So as you can see, the pocketing toolpath is going to be basically what we saw in the iMachining. Okay. We finished the floor, but we noticed something. The tool touched material in the corner. So one thing we get in mixed operations is that iMachining uses things like geometry fillet, and the geometry is cut with a bigger corner fillet, so that way the tool cuts really nice with roughing. So when we go to pocketing, we have more material left over in the corner. Well, naturally, we probably don't want the tool to hit in the corner. So now the user has to use some combination of his understanding of wall offsets and going further to stay away from the wall. And he's going to, maybe put in here, I don't know, let's try like 0.75. Because the idea is that when we finish the floor, the last thing we want to have happen is for the tool to, hit a bunch of material in the corner. Okay, it looks better, but you still need to go a little more. Okay, so now we're going to get a nice tool path. It's going to stay away. And as I showed also with the iMachining toolpath, we get this ledge that's left over because we don't, as we said, we don't want the tool touching the wall. And you can see how on the straight parts of the wall we have a different amount of material than on the floor, and on the corner. Now, this toolpath is fine. I mean, there's nothing. This toolpath here is no less optimized than what we have in iMachining in 2016. The only difference here is we are taking care of all the offsets and everything automatically because the iMachining toolpath knows what was cut. It knows all the geometry and it's shared. So this is no shorter or longer of a toolpath. It's easier for the customer to use. It's easier to get an optimized toolpath, and you don't have to play around with some of the settings and remembering stuff. And then, of course, probably from here, we would either do, we could throw in a profiling operation if that's what we actually wanted to do. I think most people would probably use iFinish, but that's up to each person. But if we did a profile operation, let's go down to our 10mm tool. Levels. So once again, we need to pick our levels from this operation to this operation. We are going to finish. Let's say we want to do equal step downs, and we can finish with 4mm steps, and we can turn on compensation if we want. Let's calculate. Okay, first thing we do notice when you share geometry between pocketing operations and profiling operations, the chains that you pick are where you get the cutting at. So one thing I do have to do is on the semi-open pocket, I need to define its own geometry that just consists of the wall. So we're going to pick up to entity. We'll start here. We'll pick to there. Now we have just our nice profile geometry. Save and calculate. Okay, now that looks much better. Now we don't have that tool path along this wall here. If we go and do a simulation, and let me just turn off the wireframe. As we simulate this, going into profile, naturally on the straight line cuts, perfect. We got a nice tool path. The load is really nice. It's going to be no problem. When we come into the corner here, you can see we have that excess material where the tool is going to over-engage. It's going to probably do a little squeak like it normally does. So I think a lot of people, when they do finishing of the wall, if they're not using iMachining iFinish in the previous version, what somebody would probably do with profile is they would probably add something like, they'd probably add like a roughing, and they'd probably leave something, as we said, probably for finishing, want to leave like, I don't know, 0.25 for finishing. And what this will do is this will actually give us two tool paths, kind of a semi-finish to get rid of the bulk of the material, and then the finish path. So okay, we get the first tool path. Yes, it's going to over-engage a little bit in the corner. you know, people probably assume they're finishing, it's not such a big deal, or maybe they just slow down the whole feed rate and they deal with it. So we you know, we get this like semi-finish, and then we're doing this in you know, multiple Z steps, which I think is traditional for people to use if they're not using iFinish. And then you get your finished wall. So the point of showing all this is to kind of give the understanding of, okay, you saw what we did with iMachining, where it was, I don't know if I like the term automatic, because it's not necessarily automatic, but the software is working with you as you're programming. It's understanding what you're cutting, and it's picking things in a smart way, so the customer doesn't have to keep track of it. And just like iMachining, everything's concerned about the load. So we care about the load even when it's finishing walls and finishing floors. And I can also show you there's something special we also do in the helical entry to get a very nice finish on the floor, so you don't get the helical entry mark. So you know, we're taking these same principles of iMachining, roughing, which is, okay, constant load, best cutting, best tool life, shortest cycle time, and we're trying to apply those same goals and those same methods directly to the finishing, and that's what we're trying to show here. Now I'm going to suppress those couple operations, and what I want to do is I want to show something kind of cool here with the roughing and the finishing. So in the first example, we roughed the pocket and finished the floor with the big tool. Well, what happens if you didn't want to finish the floor with that bigger tool? What if the tool that actually finished the wall, you want to finish the floor? And what if you changed your mind in the middle of programming? What you're going to notice in iMachining, everything is linked. So if I go back to the first operation and I say, I don't want to finish the floor anymore, if I do save and calculate related operations, you will see that the iMachining toolpath just does the roughing, and now the iFinish toolpath, instead of just finishing the floor along the wall where the wall offset was, it now finishes the entire floor. So let's simulate this, and let me turn off the toolpath display. Oh, I apologize, guys. So here is the roughing toolpath. This toolpath is not going to finish the floor. And then when the iFinish picks up, the iFinish is going to finish the entire floor. So we get the prepping in the corner, then we are going to finish the entire floor, and then we do our final finish pass. So you know, that's there to show you that, you know, we're tracking operation to operation what's being done. Are you finishing the floor? Are you finishing the wall? What's the tool diameter? We're tracking more things now than just the wall offsets and things like that, and we link it all together. Now, what I'll do just to make this kind of nice, I'll show, you know, how you could program all the pockets. So, you know, that was to give kind of a little deeper look into the little finer things we do. But the beauty of what we did is how quick it is to program. So let's say we did the roughing and the finishing on the outside. Now what's really nice is we can come in, we can say 2D iMachining. Let's say we want to cut all the pockets at one time. So I'm going to go in one operation, pick this pocket, pick this pocket, pick this pocket, pick this pocket. So there's our 4 pockets. In the first chain, we need to mark our open edges, just like we did the first time. So we're going to use our from to, and we're going to say from this to here. We're going to do the same thing on the second chain, mark open edges from here to here. And of course, when you guys are demoing or showing customers, if you're not dealing with semi-open pockets, the chain selection looks even quicker because you don't have to do any of this marking open edges. So if you're dealing with a closed pocket example, just parts with pockets, and while I was talking, I forgot to click the from to. So if you're dealing with closed pockets in your demo parts, you don't even have that extra step there. It's just going to go, a lot quicker. So we are going to go pick our 16 millimeter end mill. We pick our levels from here to here. We want to finish the floor. We want to use contour. We're going to save and calculate. This is going to get our main roughing toolpath, helical entry in 1, open pocket for the open pockets. We can do our save and copy. And now we just want to tool. We want to go to our 10 millimeter. We want to go to iFinish, and we want to, finish the floor, finish. We don't need the semi-finish, compensation, large lead in, lead out move. And there we have, I must have missed. Of course, I missed in chain number 2. That ledge. And now we get the nice extension. So you get really a very quick software now to program with. And we'll just simulate everything at one time. You get the helical entry in the one pocket. So this is not, I think a lot of us are always demoing against other softwares that try and show feature recognition and things like that in a fast way of programming. We hope that some of these new tools we have going on here allows you to show a quicker, faster, smarter way of programming. So, we're not automatically finding the geometry, picking the tools, and, automatically doing everything for you. But what we are doing is we are automatically, with iMachining, picking all the feeds, the speeds, the lead-ins, the lead-outs, the engagement angles with the wizard. We are, when you're doing the finishing and the mixed roughing and finishing, we're tracking everything. We track what was the wall offsets, how to plunge in air, what lead in and lead out to do. We're doing all these things now that the customer doesn't have to do. And because it's iMachining, it's all optimized. I mean, really, we are optimizing this at the best we can. By finishing full depth of cut on the wall, you're optimizing. You're saving cycle time. By just cleaning out the corners, you optimize. So all of these things we're doing are for optimizations. One last thing I think I should show you guys is I mentioned in the slide that we had that iFinish now includes iRest. So let's kind of show what I mean by that. So if we go back to the toolpath that did this this simple ledge, let's go in here and let's turn back on the finish floor. Now let's say for the wall offset we decided to leave a huge amount of material. So we're going to leave something like, I don't know, let's leave like 8 millimeters worth of material. and I'm not saying this 8 millimeters is something somebody would use out in the real world, but this is something to show what we're doing here. So now, if we simulate this toolpath, what you're going to get is you're going to get the toolpath, and guess what? You're going to have 8 millimeters on the wall. So there's this huge chunk of material. Now we're going to go to iFinish, and we are going to calculate this toolpath. In the current version, what you guys would, if you guys are using iFinish, what you would know is that iFinish, if the previous material was larger than what the finish final pass was, you would get a message that said, the previous wall offset was larger than the maximum step over, and you would have to either add some iRest machining operation in there. Now we take care of that automatically. So now what you'll see, sorry, I started playing that a little quick. Now you'll see that this iFinish operation knows that there was a lot of material left on the wall, and what it will do is it will do a rest machining to bring the wall into the wall offset defined, because in this operation we have a wall offset of 0.3 because that's what we want to finish with. We want the finish pass to be taking 0.3 millimeters. So now we also add this second like prepping operation. Besides prepping of the corners like we normally do, we also take care of the rest material. So this is once again less operations. Shorter programming, easier to program. We've removed some limitations, we've enhanced some things, yeah. So this is some of the stuff we've done for finishing, and there's more things in here, and maybe what I should just mention real quick is the things that you'll see different in the operation, because it's not much. When you do iFinish, you're going to see a finishing geometry fillet, because the roughing is always going to go with the roughing geometry fillet, and then you have a finishing geometry fillet. In the feed and speed section, we've always had spin rate, spin finish, which did the wall, and spin helical. Now you also get spin floor. So in this one operation, you have separate feed rates and spindle speeds for roughing, finishing walls, helical, and for the floor. The iMachining wizard is calculating the finish feed rates and the finish RPM, but of course these a lot of times are left up to customer desires. So you can always come in here and change any of the feed rates or RPMs. If you want to override it and finish the floor at a faster feed rate, you can. Finish the wall at a faster feed rate. The customer can change them, even though the wizard is calculating them. And then on the technology tab, we've always had the finished floor, but now you get a choice between contour and iMachining. If you pick iMachining, the overlap goes away because iMachining uses the engagement angles from the roughing. So if you have a part that, let's say something like Inconel, Ahmad was cutting the part with Inconel, even though you might like the look of a contour style on the floor, your tool life, even cutting that 0.3 millimeter on the floor, it can get beat up using that traditional style pocketing toolpath. So you still might want to use iMachining for finishing the floor. So you can still choose iMachining for finishing the floor, and I think in hard materials, I definitely think this is a useful feature to have that. You also get a semi-finish now, so you can do semi-finish, and the whole thing with probably semi-finish is that you can cut a more accurate part, or it can also be used if you're going from a big tool, a 16 millimeter, and you need to finish the wall with let's say a 4 millimeter cutter. The wall offset you leave, you probably don't want to jump all the way from something like 0.3 in one pass with a really small tool. So you can throw in a semi-finish in there, and when you click the semi-finish, we automatically divide the wall offset into two, and we take half the distance. So that way you can that way we at least, put something smart in the UI, and the customer has the option to change it. Like, with everything in iMachining, we're always trying to, pick some good settings, pick some good parameters, but we leave it up to the customer still to be able to change, what he needs to change. So we can exit this, and let's go back to our slides real quick. Okay, precision machining. So this was something, I just talked about with semi-finish. One thing, I think we see more in machining nowadays is that customers circle mill bored holes or tight tolerance holes. So we've seen, we heard from some customers and saw how they did tight tolerance features, and a lot of those customers use some combination of a semi-finish with a spring pass. So now also, even in iMachining 2D, even for the most part, as I said, I don't think you would use a semi-finish, and I don't know that you would use a spring pass. If you're trying to make something highly accurate, you have the combination of semi-finish and spring pass. You could use them both together, or you could just do, a spring pass or just a semi-finish. But we've thought, we've put some thought into this from what customers have said, that they should be able to machine something precision also with the finishing tools in iMachining. Still not as powerful as profile, and I think that's important that everybody realizes here. But the stuff we've added to iMachining, it's to do, like, I don't know, maybe 80-20, 80% of the work. The customers still need pocket and profile. I mean, there's so many more options in pocket and profile when it comes to, controlling the tool path and multiple passes and things like that. So, we've tried to take, let's say, the most common things in profile and pocket for finishing floors and walls, but still customers are going to have to go back to profile and pocket to get certain geometries cut and to do what they want. So this is, once again, complementary to pocket and profile, but I think you can use this much more, and the customers can use it much more. All right, we can go to our second feature, which was our helical entry for the drill tip. And okay, I don't even know that we need to really go over the slide, but here you can see the helical entry cleaning out the drill tip, and here it isn't. I think it's more exciting to actually see what we do. And pre-drill example. And let's show the updated stock. Cool new feature in 2016. I love this feature. So we're machining this pocket here, and we have a pre-drill. And what we can see is that part of the tip of the pre-drill is sitting above the bottom of the pocket. Now, when you pick pre-drilling in SolidCAM, and I will I'm going to turn off the updated stock. Let me open up this operation. For anybody, I think everybody knows about pre-drilling in iMachining, but previously in pre-drilling in iMachining, we knew the tool diameter, we knew the X, and we knew the Y location. Now, we don't display it in the UI, but I think this is something we will do. We now track the Z bottom of the drill, and we also track the cone. So we know the 3D tool, and we track it. So in this instance, part of the tip is below the pocket, and part of the tip is still up above it. You are going to get an iMachining helical entry that machines out the tip. And if we simulate this, so you'll see we'll go down to the bottom of the pocket. We'll do our helical just to clean out the tip, and then you get your your iMachining toolpath. So the thing here to see is that we are tracking the drill. Now let's go into the drilling operation, and let's just say we we have the bottom of the pocket, which is 21 millimeters, but we had cutter tip and we were using a delta. Now we're going to go full diameter, and I think this is what most people would do. They would pick the bottom, and they would say, okay, I want to go 1 millimeter past, and I want the full diameter. So we're going to calculate that. We'll calculate the iMachining toolpath. And now you'll see the iMachining toolpath no longer does the helical entry, because if we simulate this, the tool can plunge all the way to the material, all the way to the bottom, without plunging on the tip. So no UI change. You know, this is not something you're going to see. There's no extra UI. There's no extra settings. Just now we've updated the pre-drilling to know about the previous drill, know about the tip, know about the angle of the tool. If the tool also has a flat, we track all that, and we see if any of the tip is left over in the iMachining pocket. And if it is, we do just the helical entry just to clean out just that area. So really not too, not too much going on, not too much to see there, but I can say that this was a pretty highly requested feature from people who use pre-drilling. And then the last feature we'll go over is fixture collision protection in iMachining 3D. And this one is really cool because I think everybody has always wanted fixture avoidance inside of SolidCAM. So now in your setup, of course, if you have your fixture, we can now use it in iMachining. So in iMachining 3D, what you're going to have on the geometry page is this fixture collision protection, and you're going to get a clearance. Now, this is also working in tandem with the holder collection, the holder collision protection. So, you protect against the holder, and you can also protect against the fixture. In this example, I don't have a holder, so there was no point for that to be on. But let's go into the Solid Verify. I have one operation set up. I mean, there's no point to, there's not a whole lot to actually program here, so I'll just show the toolpath. So I made one toolpath. I cut the top of the stock because I thought it was neat to see that just doing an iMachining toolpath to the top of the part, you can see it move around the fixture, and of course, most important, you can see that half a millimeter offset. If we go to HostCAD, show the toolpath real quick. So here, once again, nice picture of the toolpath. You can see it moving around the fixture. And then I have the same thing for, then I have a second iMachining operation just going from the top to the bottom. I'll simulate this in Solid Verify, but you can see we stay away from this fixture. We stay away from the bosses. We know over on this, we know that we can cut over top of this little part of the fixture. So if we go into Solid Verify and play this, you can see the iMachining toolpath properly staying away from the fixture. And of course, the most important thing here is the fixtures are 3D. They're not 2D. This isn't a working area. It's not like we just take the silhouette profile of each fixture and just don't put toolpath up above it. We actually manage the 3D fixture, and the holder moves around it, the tool moves around it. Everything is tracked in 3D. So this is my one example, and I just have another example which I think you guys will see in the what's new and fixture example 2. This is a nice example Sydney made. So here's just a part, plate, and common thing, bolt holes, right? So bolt holes to clamp down your part. And if we look at the iMachining toolpath, nothing extra the customer has to do. Define your fixture, click in the operation that you actually want fixture, fixture collision, and then you'll get your toolpath that moves around it. And let me do this in Solid Verify. And we can just, you'll get to see the cool iMachining toolpath. And actually, I like this example that Sydney created because you actually get to see some of the channeling and, that we do, the moding. And you can see some spirals. You can see here, like, we're actually splitting. We actually split this. We split it here. We get a spiral. We get a spiral. We get a spiral. Get a spiral. We prepare. We get a spiral. So, I mean, besides the fact that this is a cool little part for the fixturing, you also get to see some of the smarter toolpath features with, separating channels and spirals. And that that concludes the what's new. So I think, Eddie, I think we can open this up to any questions if there are any. Eddie, are you with us?
Yes, Anthony. Thank you very much. We got many questions through the webinar, and
Okay.
part of them we already answered to save the time at the end of the webinar. However, we still have questions, and of course, guys, you can continue to ask your questions. So this is the question, Anthony. Had we had a fillet between wall and floor,
Fantastic question.
to what extent will it complicate the iMachining options?
Okay, so this is we had okay, so we're talking about a fillet here in between here. So as of today, you could use the corner radius, and as long as all of your tools have the same corner fillet, SolidCAM will track everything. But and this is a feature we're going to work for SolidCAM 2017, because this is one of the first things we saw. If you use a corner radius, we will add that corner radius into the geometry page in SolidCAM. So there will be an extra field for the corner radius. And what we will do is, if you are using tools that have either sharp corners, or let's say your roughing tool has a corner radius that is smaller than the corner radius that's in the part, you know, because for aerospace parts, a lot of time there's like a 2 or 3 millimeter corner radius, but you might rough with a tool that has, you know, a sharp corner. We will manage it automatically. So so the basic answer for today is, if you're doing corner radiuses and all your tools have the same corner radius, it will work. In 2017, we will enhance this functionality so you can tell us the corner radius, and you can use any mixed combination of sharp, smaller corner radius bullnose tools and larger bullnose tools, and we'll properly take care of, you know, roughing and moving around the corner radius. So it's a very good question. And it was one we had hoped to get for 2016, but we didn't have the time to finish it. But it is high. It's high on our list.
Good, Anthony. Thank you very much. By the way, we continue to still get feedback now in the webinar chat. Great enhancements. We got it from Germany. Yes, good job, Anthony. And thank you very much for being with us this very, very early morning in Pennsylvania. Good job. And there were many, many partners in this webinars. We answered many questions personally. And guys, I just would like to tell you that this great iMachining development team, they continue to work hard, and I can guarantee you that you will be happy with the next version's enhancements in iMachining. Don't worry, we will keep to put it out of competition. You will have the best tool to win every deal. Thank you very much, and we hope to see you next webinar again next week. Anthony, you can go to sleep. Thank you very much.
Thank you very much. Yes, I'm
going. Bye-bye, guys.
Appreciate it.
Thank you.
Bye, everybody.